series called Expert Speak, hosted by the International Association of Business Analytics Certification, IABAC. Our speaker for the day is Ms. Sandhya Haridas, and the topic she'll be covering today is on smart flying and explainable artificial intelligence applications. We also have with us today the advisory board member of the IABAC in Netherlands office, Mr. Hans Bokers, and he'll give us a brief introduction of the speaker today. Over to you, Hans.
Thank you very much. Welcome everyone to this webinar about smart flying and XAI applications. I'm Hans Volkers, co-founder of IBAC, and I want to introduce to you our speaker of today, Sandhya Haridas. She is the Director of India Delivery Operations of Schneider Electric. She has more than 23 years experience in tech-driven roles, delivering IT solutions, analytics, and AI-related projects. She aligned the business goals of numerous large projects and programs to achieve optimal results. She did that many years in aerospace and other high-tech areas, but she also found personal motivation in social activities and developments for children. May I give the floor to Sandhya Haridas.
Hi, Hans. Hi, everyone. Am I audible?
Yeah, you're fine, Sandhya. Thank you, Hans, for the wonderful introduction. And let's start the session for the day. Just a quick update, we'll have a quick Q&A session at the end of this presentation. And I request all the participants to post their questions in the chat. And we will try our best to take as many as possible at the end of the presentation. Over to you, Sandhya.
Thanks, Ram. Hi, everyone. Again, good morning, good afternoon from wherever you're joining. Happy to be here and excited to share the topic on smart flying and explainable AI applications. So this is something which I've been working as my PhD course. I'm doing my doctorate in AI. And smart flying is something that we have been looking forward for as we move ahead, connecting the world. So obviously it's on the top of everybody's mind that everything should be faster, quicker, and on the other side of the business, it has to be more profitable. So I will take you through very quick and brief information, possibly what I can share in this 1 hour, and take possible questions at the end of the session, 10 minutes before, and we end the session here. So what exactly we mean when we say smart flying? So is this not digital flying? Yes. So when we say smart flying, it obviously has to be something related to internet, very right, and it has to be something to do with the infrastructure, people, and the technology, the processes. So a lot of things that actually we can talk about. And before moving forward, very thoughtful question like, how is that we are so well connected today, across the globe? So that is only through, possible technology in the aerospace industry. So thanks to aerospace industry that actually keeps us going and connecting to various parts of the world. And that also has its own challenges and limitations. Let's understand, move ahead. What could be those challenges? And how we are planning to evolve that.
Sandhya?
Yes.
Quick thing. Are you sharing your desktop?
Yeah.
We don't see it.
I'll just share again.
Yasir, can you make Sandhya the co-host again so that we can see her desktop? Yasir?
If you can see.
Yeah, we're good now.
Good. Okay, thank you. Okay, so I will move ahead with the flow. So we were talking about how digital transformation is overtaking the aerospace industry as well. So why are we talking about this topic today? So basically, when we go back and understand, India being one of the largest country with respect to the population and as well as being the hub for the business center, we have drastically seen this changes in the era that there are lot of aircrafts, lot of airlines that actually come forward, and it's making a very common man affordable to use the aircraft as a mode of transportation today. So what happens when these kind of opportunities are given in countries like India, where we have the airline coming forward and making it more possibly affordable for all class of society of the people in the country, and moving ahead, it has been a very popular mode of transportation across the globe as well. So the statistical data and the internet survey, we understand that there are a lot of global airlines that actually helps us connecting and touching numerous people from corners across the world, and it is making it more affordable and sustainable mode of travel. But are we ready with respect to the infrastructure is the first question. But obviously, the airport's not able to handle the larger number of people, and there is the demand is always growing high. The check-in processes are long queues are waiting lines are big, and there are shortage of airline staff and as well as industry that operates in a lean process. So this actually being the major challenge. So what is that we can do? Because as we know that with the data that what we have, so it calls for certain solutions. We can go ahead and use those data to solve the problems. It could be something like what I have basically shown here, the breakdown of customer complaints with respect to baggages or the reservation, ticketing, boarding. So these are various buckets that where the complaints or the issues that what we see as a challenge, because of the n number of travelers coming in and moving out, and they have certain challenges what they have faced. And this is as per the survey report that where people actually have gone ahead and recorded their complaints. Now, with the technological advancement that what we have, can we use that data possibly to make that actually some kind of a solution is? So where this data actually can give us rich avenues and can give us vast opportunities to improve the business and operational process, and as well as customer satisfaction, which is a key success for any of the industry, right? So with this, actually, it becomes more evident for us, where we can go ahead and have this data utilized for the business opportunities. And as such, airliners themselves have their own challenges. We'll see how things go ahead and we can make this possible now. So as I said, for us, it becomes very important now that we are facing so many challenges. We have understood what are these challenges. We have faced personally those challenges when we have been traveling. So I came up with this idea as a part of my doctorate, where I wanted to utilize a few of the machine learning and as well as AI possible concepts to go ahead and leverage to these opportunities. So I introduced something called as smart flying, which basically refers to the integration of advanced technologies such as AI, that is artificial intelligence, IoT, Internet of Things, and automation of certain processes. So what actually do I want to achieve, right? What is the goal? The goal is to have smart flying for across the passengers across the globe, which probably will improve the efficiency, safety, and sustainability of the air travel. Now, let us take point one, where I'm trying to leverage AI to analyze a large amount of data, such as flight schedules, weather patterns, maintenance records, to optimize the operations and decision-making processes. So that is where I'm talking about this bigger block, what you're seeing on the role of big data in aviation industry. Today, data is something that we are able to access and also give the access to others, right? We have been exchanging data knowingly or unknowingly. This is something that all of us know. So when you try to do your web check-in, so what are the information that you're giving? What kind of data you're giving? right? So there is an intelligence that is built back end, where there is a smart tool collecting all the information. And what are they trying to do? They're trying to possibly access information about particular traveler, how frequently you travel, what kind of traveler you are, how much of baggage do you carry, what kind of challenges probably they should be ready for, what kind of infrastructure you're living, you are actually looking for. So this kind of data we are giving. So that is where you see customer segmentation, demand forecasting, optimized flight route, centralized view of the customer, fuel efficiency, giving out personalized offers, smart maintenance, performance measurement. So lot of data that can be used for this big data in the aviation industry. So this was a few examples that I gave when you give your personal data that can be used for obviously customer segmentation. And also based on your the kind of data that you give, they can also possibly design the personalized offers for you, especially for you. Similarly, on the performance measurement of aircrafts, performance measurement on particular staff. So a lot of case studies have been carried out where these data are huge, humongous data that gets into particular database. And based on that, lot of analysis are done. That is about how we can leverage the role of big data. And from there, we actually move one step ahead where ML is used. I will touch upon that as well. And then we go ahead and use AI. So AI being the the major chunk of the whole journey there. And the second part of my concept for smart flying is about IoT. So we're all aware about the Internet of Things, the devices that how our smartphones, our smart homes, smart cars are very well connected. So what stops the aerospace industry to not to explore this, right? So definitely we can take advantage of that. So IoT devices are used to monitor what basically the health and performance of the aircraft in the real time. So obviously we want all the information live, all the information in real time, right? That is possible. And proactive maintenance, reducing the downtime. So how are they doing this? Because when the pilot is traveling or he is using certain apps, is letting go certain information from the aircraft to the ground and various other sources of the channels of information. So what happens here is the end devices are able to collect the information, and there is already a kind of an application that is built which is on continuous learning. Whatever the data that is dumped here, the model is made so intelligent that it starts processing, it starts synthesizing the information that what actually is coming from various sources. And there are certain KPIs where pilots actually have been asked, to use certain SOPs, that is standard operating process. So whether the pilot is using SOP or not, even that is monitored, right? There are certain FAA regulations, even those things actually are monitored. So real-time information are given by these IoT devices. So obviously, even for us to reduce the challenges, what we have on day-to-day as a traveler, IoT can help us to understand certain challenges and process the information. And the third part of the smart flying is automation technologies, which can be used to streamline the processes such as baggage handling, flight planning, improving efficiency and reducing cost. So here we are talking about various personas. So as you see in my screen, I'm talking about the passenger is one persona for me, flight crew, MRO, airline supporter, and so on. So each of these personas get benefited by smart flying. For example, if you ask me as a passenger, I have given few case studies, and I've also mentioned few examples here, like baggage handling. That is actually a biggest challenge, where there has been a tremendous study done how the airliners actually lose out certain revenue because they have to compensate the passenger when the baggages are misplaced or when the baggages are lost. It is their responsibility, right? That's what we think, but they think it should be our responsibility, but finally they land up paying. That's again a a revenue leakage for them, and this can be controlled. This can be brought under control using certain automation technologies, where certain RFID mechanisms can be used to track your baggage loss and things like that. Similarly, moving ahead, one more advantage of using AI in the smart flying is also to recommend the use of alternative fuels or the electric propulsion system to reduce emissions and also improve the sustainability. So when we say smart flying can really help us is because today, as we are moving ahead, it means to say that the more a person of his transportation, that means he is actually emitting more carbon dioxide. So that is where you see when you do your when you have your boarding pass, I think you can really see how much you are contributing for that, in carbon emission. I don't know how many of you have been cognizant about that, but it is something very important. And as we move ahead, I also feel this will be something very attached to your unique ID, where you will become responsible for the environment, in saving of the environment. And if at all you can avoid traveling, you can avoid a certain in carbon emissions, I think yeah, that is good. So these are all some things which all comes together using AI, IoT, and automation technologies. That is what makes smart flying. And I'll move on to the next slide. So here we are talking about explainable AI and generative design. So what exactly AI means? We know AI actually is very simple. Today to say that artificial intelligence is used everywhere. And what makes my system more relevant or to be more transparent or understandable. It is doing the same kind of job. Once I put my codes into the learning patterns, what I want to use as use cases into the ML, ML throws out so many outcomes. But when I go back and ask my data scientist saying that, okay, why did you get this kind of an outcome? When I'm not convinced why the ML or the system actually has taken this kind of decision. It's a black box. We don't have answers for that because it all works on certain combinations or the permutations, the logic that what we have given. In order to understand, how the decisions were made, are the decisions right? Are the decisions relevant? So that is where, this explainable AI comes into picture. So explainable AI is the most happening and the most transparent AI today in the industry. So everybody are vocal, and especially in industries like medical, legal, and aerospace, this becomes more obvious for us to give more information to the stakeholders on the decisions, on the accountability, what basically we have taken as a end user or as a person where we are trying to make something work for them. So that is where more and more companies are also are embedded with AI, and there are certain advanced analytics that used within a business process that actually is feeding into this algorithm or the logic, isn't it? So that is where it becomes important for any a person who's working on particular opportunity to develop AI to have these 4 principles in place, in a very important category, and a lot of important decisions are based on this. So the principles that AI actually XAI is built is explanation, meaningful, explanation accuracy, and knowledge limits. So when I mean when I say that explanation, what it means, explanation is that AI should be able to give proper and definite information on how the logic was built in maybe various ways, but the end objective is that whether your explainable AI actually is built on these 4 principles or not. That is very important. If it is not built, then you will have to have a lot of iterations, right? You cannot just go ahead and provide saying that, okay, something I have built out of ML and ML is giving me certain outcomes and I have used AI and now this is outcome. No, it doesn't work like that. So it has to be based on these 4 pillars. Then it has a meaningful outcome, correct? So here a small graph that what is showing is the percentage of airlines with AI use cases that what currently have been implemented. So you're to see, like, if at all you log in any kind of, for example, like, in Lufthansa, or like, British Airways, or even Indigo in India, right? So there are certain bot systems, chat bots. So what are they trying to do? We have faced this in banking industry and other industries, but probably, like, in aerospace or in airlines, people actually are not being very open to use that. But I would recommend that most of your queries are answered using these virtual agents or the chatbots, where your primitive information are actually fed in, and they're trying to remove the most of the human interaction there. So that is one of the cost optimization, to remove the people attending on your calls and things like that. So chatbots are very effective. So this actually has gone up to 85% in almost all airlines. They have actually implemented this. Similarly, 66%, right, of the global airlines, they are able to go ahead and adopt predictive analytics. What does this predictive analytics mean? So that means, like, there are certain data where it actually gives information beforehand, saying that there could be certain failures in the aircraft components, or in systems, and how much time they will take to come back and make it functional. So that is something which is very helpful for the different personas, may not be for the customers or the passengers there. And similarly, targeted advertising and personalization, 63%. You're seeing how each data actually have been bucketed and they've been used for various analysis. Pattern recognition, brand perception, and automatic scheduling. That's example of repairs, maintenance, and things like that. So this all actually comes under where we call as connected data. So once the data comes in, and we start segregating into various buckets, and then we understand using ML how actually each of this data can be used for various end users. Okay. So similarly, today we're also talking about developing certain algorithms based on minimum information. But as we go ahead, the use cases may may be added. Maybe I think different personas will need different applications, different outcomes of these algorithms. So what do we do in such cases, right? In such cases, we have something called as generative design. So this uses a kind of a flexible platform where the algorithms can be enhanced. There is a certain applications or a logic developed where it learns. As you start putting on more information, more data, more personas, or more use cases, it has automatically developed kind of an ability to learn out of those inputs what you're giving, and start developing for the next challenges that what a end user may need, or a various stakeholders may need. So that is where we try to develop XAI and generative design together, where we can go ahead and make the system ready for next 5 years, right? So that is a platform we're trying to build. So this is very common as most of the industries. So where they're actually trying to use generative design and AI come together. For example, this can be used even in the in airports. For example, the design of the airport, like what they're trying to develop now, and is the airport ready for the next 2 years or 3 years to take that advanced technology for the market demand. So it is obviously a kind of brainstorming session, but a futuristic thought, or a futuristic visibility that is required as we go ahead. So this is something that I want to touch upon, where basically what happens in the normal scenarios, how things actually have been perceived today, and what we are going ahead, how things may look like. So a typical ML model, I don't understand at the end of it, where I stand, why certain errors have come in, why certain decisions actually have been made. So that is something like a black box for me. But what happens in the explainable model, that is we are talking about tomorrow's, that the technology that is very much evident that we are seeing changes are so fast. So when we bring in this explainable AI, so it tells us, okay, that there is a data which actually trains the whole thing. And because of that, we are actually having a new learning process, right? And from there, I have a very structured way of understanding things using my neural network and trying to segregate things and build an explainable model which is like very clear and which actually helps me to have an interface which is very transparent and which is having certain reasons why certain decisions were taken. Believe me, ML actually it just develops what is exactly is required out of the algorithm you have developed, you wanted, but it is still a black box. There are certain things that why did you do that? If some questions are asked, we don't know. Certain user tasks are provided. There is certain information. There is a failure in the system. There is no reason. But if you try to bring the concept of XAI, you're able to every step there is certain information. See, like on my right hand side below here in the box, I'm able to define, right? So what is this? If I'm telling it's a cat, here you see we are given certain value, right? That is how we have been trained. But now as we go ahead, there are a lot of information that comes. That means we are trying to be vocal about asking questions, ask more questions, and you're trying to probe the system and you're trying to understand the logic and question why that logic was put in. So that is where the whole information comes in handy for us, and we try to go ahead and have these 4 principles as I explained are in place. So it's very clear that I understand why and why not. Yes, I know I will succeed or I'll fail. It's very clear, right? And that is where the trust is building. Okay. So how XAI or XML, they are both the same. Explainable AI or explainable machine learning. So they mean same. How are they helping us, right? So the boom that what we have in the ML and AI, that actually is making us think about a lot of opportunities and come up with an iterative process and help the customers, especially in airline customers, that what we are talking today is very effective. And it has been widely accepted, and also it plays even more important role in driving efficiency, as I mentioned, coping with upcoming design, and as well as mounting to the market pressures for the cost optimizations. So the cost optimization is like one common requirement across all industries, all verticals, where today we are talking to any startups is we do ask for cost optimization, or we are talking a big multinational organization, we still talk about cost optimization. So that means to say certain logic should be developed even beforehand, like when I develop certain algorithms. So how is that possible to cater to those requirements as I move ahead and make make my model more efficient and also more cost optimized. So these are all into 2 different things, but we still have to see that there is an equal balance. And similarly, it is what is explainable AI? As I mentioned, it's a processes and methods that allows any user to comprehend and trust the output that actually is created. And all these outcomes are actually based on certain algorithms provided by a data scientist or a solution architect, whoever it could be, who's working on that. And it helps us to have a fair model to understand that, okay, this is why the certain decisions were taken. And when certain decisions are taken, obviously you cannot interrupt the mission saying that, okay, now stop. I'm not okay with this decision. Can I go back and work on this? No, then you'll have to give certain other logic for that if you want a different outcome. But if AI is actually intervening certain outcome, that means it becomes more, the model becomes more intelligent for you to go and have these kind of outcomes, which is transparent, which is having accurate outcomes and fair enough outcomes, and in certain model accuracy as well. And so we know that all of us are under tremendous pressure when it comes to providing certain profitability, even at our organizations, that actually still becomes a big challenge, saying that, okay, you have a certain number of challenges and you still have to overcome that and still meet the revenue targets, right? So this is same even in airlines, we see that more. And because of the cost that what actually is involved, that is very, very high. The investments are very high, but still they'll have to utilize. It's a high time that few of the airlines have already adopted to certain AI models, and few of airlines are still trying to work it out, or trying to experiment at a certain point of time. But it will become very common as we move ahead in the aerospace industry. as I said, immigration is one of the important and as well as a challenging, activity for the immigrant people who actually are getting migrated to different countries, and the migration officers, they have their own challenges. And recently, US actually had declared that, there are, I think probably in 5 years back, the kind of challenges that they faced for the immigration process to set up. And it was all so much of time consuming, and they still had illegal immigrants entering the country, and they had a lot of the legal and so these things are actually again I'm working again with the legal immigration office, back end office, where they are certain interviews and saying what are the challenges. So that is my survey, that what I mean across use cases for them. And so that also becomes one of the deep study to understand can we reduce the immigration checks, the process, which is so very complicated today. And why is it so complicated is one reason, is we are trying to understand that. But is there something that we can bring AI into the picture? So obviously explainable AI is the best solution for that, where it is more transparent, it is more trustworthy, and it has a lot of other features which can be implemented for an industry like this. And as we move ahead, the survey also says that year on year, there is going to be 3 to 6% of increase in the air travel of how the people actually are going to be traveling from one place to another place, and it's going to be incremental in the next 10 to 20 years. So the question is, as I been explaining, are the infrastructure ready for that? Are are they in the process of bringing up their infrastructure to the expectation to meet these demands? So that is where the whole am I good, Ram?
Yeah, are you able to? Are you sharing the screen?
Oh, you're not able to see the screen again?
Yeah, can you try and do the share again?
Okay. Are you able to see the screen now?
Yeah, just a moment. We still not.
It says the host has disabled the participant screen sharing.
Can you try now?
Definitely. Yes, now it is enabled me to share.
Yeah.
Am I good?
Yeah, we're good.
Thank you. Yeah. So this is again a few of the applications using XAI. Obviously, a few are a little familiar for us, but as we have few of the opportunities here. I'll still go ahead and make you more familiar on these use cases. So first is on predictive maintenance, where we have been talking about this as a big challenge within the aerospace industry. So today, Airbus and Boeing, which is actually high on the passenger aircrafts, they're also there on cargo, but passenger aircrafts giving them the maximum revenue there. So predictive maintenance is actually something which they're very much implementing in their industries. So AI algorithms are used to analyze vast amounts of data, and that is basically on how the systems actually are performing, how components actually are prone for failure, and what are the warranties of their components and the systems. Right? This kind of information actually helps them to create an algorithm to have the predictive maintenance. So we had something with working with Airbus, where we had certain information go beforehand, where they have an application called Skywise, and where every component actually is gone from the day that gets into the aircraft till how they've been performing. This information are operational data that actually is collected, and there is an algorithm built to understand, okay, for every takeoff and landing, how much of wear and tear actually is happening, and should I be prepared? When should I be prepared to replace this particular component? So when is the next maintenance that is? This is similar to the car, right? When we are using a car, we have certain maintenance that is required. So similarly, an aircraft being more complex, machine by itself, and numerous dependencies on each systems, so it becomes important for us in the aerospace industry to understand what goes in and what are the particular timelines that I need to replace the components, or I need a certain repair, or when does it possibly going to fail, right? This kind of information comes from predictive maintenance. And how does it help me? Because I know that next 6 months or next 3 months is something that this particular component, it could be brakes, it could be APUs, it could be certain components within the engines, right? So the time where it is on ground and how actually it can come back to operational. So that lead time actually is something that the airliners or the aerospace industry will try to reduce and bring that optimization as a part of profitability for them. Moving on, fuel efficiency is another important aspect of XAI, where AI actually helps to power flight optimization software that can analyze the flight data to suggest the fuel efficient routes. And for example, there is a constant pressure on the airline industry to optimize their flight routes, because that is one of the additional cost for them, where they can save fuel and as well as the time. And you must be seeing, there are certain challenges where the air traffic control also has to give certain clearance for these routes. And every time, there is a constant search, constant study on that, where they can obviously, optimize that routes, and as well as, make it more efficient for their fuel efficiency. And few pilots, as I said, they also have certain processes where they have to operate in certain ways so that their efficiency, the fuel efficiency goes high, and that actually helps them to reduce the fuel consumption and as well as emissions. So this is two benefits out of one protocol. And next is on the component design. Here, AI also assists the engineers in the design process by generating virtual prototypes, and we're able to simulate them and identify where are the areas that what we can improve. And said and done, supply chain optimization is again one more opportunity across the industry, but in AI it is more, because most of their components are spread across the globe, and they have a lot of human intervention, lot of follow-ups, lot of challenges, which actually AI should help them to improve those logistics and improve that speed and accuracy and reduction of the cost ultimately. Customer service is, as I mentioned, AI chatbots are provided there, where the human intervention can be reduced as much as possible with respect to the air ticket bookings and cancellations and things like that. And flight schedule, again, the flight schedules you see most of the time the airports are all full. They're always 24/7. The utilization is there, and the peak times are measured, and sometimes we do know that, okay, this is a peak time and I should not be taking this flight, the cost is going to be high, right? These are all various things that where your AI actually helps. So here also, AI actually helps us to optimize the flight schedules by considering various factors like the delays, fuel cost, and the maintenance requirements. And there is a fraud detection. AI also helps in that, and such as the ticket fraud, baggage, and loyalty program fraud, and things like that. Personal marketing, here again, it actually helps to analyze the customer data to provide personal marketing recommendations, such as destination, the hotels based on your individual choice. So there is an AI built when you log into your laptops, your smartphones constantly, that is what we call as NLP, natural languaging process, where it's trying to access your information and start throwing recommendations based on the past information that what it has collected. So that the same information, the same logic is used here. So similarly, flight safety, which actually is a major, important aspect. So AI also can monitor flight data in real time and detect the alert pilots and ground crew of potential safety issues. So few of the experiments which are actually have been done, like simulated based on past catastrophic accidents, and there is an AI which is built to understand why those accidents happen. Like, maybe the Boeing 737 that actually landed up into ocean recently, in Malaysia, right? So similar accidents are such an information are fed in to understand the failures of the aircraft, what possibly the decisions the pilot could have taken. Right. So these kind of informations are fed in, and there are certain simulators which provide information saying that, okay, I think probably you could have taken a different route, or you could have tried for some ground help. So various aspects that actually comes into picture, and AI actually is trained for that. So these are various XAI applications. I'll move to the next one. Okay, so said and done, these are actually what is happening, and next, what are the next step? Where are we heading to, right? So this is a tremendous, high demand industry, because as we know, today everything has to be on a speed, right? It has to be on the mode of fast and quick access to everything. So obviously, if somebody is traveling, or even if you, very simple example, like you order for a product and you want that product to be delivered, and like suppose it is somewhere the destination, the way the product has to be delivered is somewhere in US. What do? We ask for air freight. Can it be transported by an aircraft? Right? Or like even I have certain urgent requirement to meet somebody, some of my acquaintances in US, UK. So what do? Then I know that I have to take the quickest flight. So today it is all about time. Nobody actually wants to wait. So in a scenario like this, so obviously, the demand for new aircrafts, or the aircraft deliveries are very high. So what I'm trying to explain out of this slide is, you see how many aircrafts, in the new passenger deliveries, then you have new cargo deliveries. So this is something is going to be expanded, right? It is where we are trying to see that it is one is like affordability, and the demand is high. How do I meet that demand, and how do I bring in more infrastructure to control the other aspects, other personas, and the challenges that what it's throwing at me. And similarly, there is certain licenses, there is certain aging for each of the aircraft, and once that aircraft actually meets certain requirements with respect to the years that it has been flying, then there is an opportunity where I convert that passenger to cargo flight. So that is where you see at the center. So few of the passenger aircrafts gets converted to the cargo fleet. So, but the continuous ask of the aerospace industry or the airline industry is whether it is passenger or it is cargo, what is the revenue I'm making? So is it constantly giving me a fixed amount of revenue, whether the aircraft has been aging X years, or 10x, 20x. I'm not worried about that, but it has to generate revenue for me. So this is a fixed goal. So similarly, you see 8,433 flights, passenger retirements, and then cargo retirements. But still, this also can be once the cargo fleet, once I finish that, what do? I go back and use that for MRO. Right? So certain aircrafts are dismantled, and these components are also can be used. There's a different market, after segment market, what we call, and this market is huge. As finished its fatigue life, or where does it stand? Do I still have certain life in that particular component, and can it be reused? If it has been refurbished, what do? So this is constantly generating revenue, where we are evidently seeing that the prospectus opportunities are enormous, and there are various group of the sector of industries which emerges over a period of time to come up and work for each other. So this is an ecosystem that actually is built in. And going ahead, as we know that Industry 4.0 also talks about how are we going to make it sustainable? How are we going to bring environment, more eco-friendly system that we need to build? So this is going to be the challenge for any stakeholders in the aerospace industry to build an AI which gives you all that transparency, all that explanation that is required, all that accuracy we need, and also what kind of white box or black box information at the end of the day. So this is what I had for today's presentation, and I'll leave the floor open for the questions.
Thank you. Thank you so much, Sandhya. Yeah, we do have some questions, and we have Priyadarshini. She's asking, how does XAI address concerns about the potential biases or errors in AI-driven decisions during flights?
Can you please repeat that, Ram?
How does XAI address concerns about potential biases or errors in the decision making? By using AI, right? While doing in the flight, yeah, in the aerospace industry is what I think she's trying to get at. How can we identify biases and errors in the training model? Basically, how we go ahead and train the models, right? I mean, I say basically that data sets is what could potentially create this kind of thing. But I think she's trying to look at that part of it, like how we train the models.
Yeah, so XAI gets into a deeper level of asking lots of probing questions. Similarly, it can understand whether you are trying to take particular questions in a particular direction, or you're trying to answer those questions in a way that the model needs it. So if at all it is like biased, so obviously your outcome is also going to be biased. So that is how the AI is trained. But the explainable AI makes a decision based on how you're going to be answering to all the stakeholders, right? And all the users who actually are part of the particular model. And so as I said, accuracy is something which is very important for XAI, and also explanation when you're trying to give this particular information. For example, the developers or the end user is somebody different, and similar questions will be posed to 3-4 stakeholders who are part of this development. So obviously, the questions asked are completely different from each of the stakeholders, and it has to be not biased, it has to be unbiased. It is completely based on how you are looking at and giving a bigger picture to the end user.
Got it. We have Deepak asking, are there any regulatory or industry standards that govern the integration of the XAI in aviation applications? Are there any standards? Is one of those questions.
Yeah, so there is something called Department of Defense, DOD, what we call. So they are actually facing these challenges where certain MLs started giving errors, and they were not able to understand why these kind of decisions were taken. So that is why they started pushing this XAI as a concept for industries legal, aerospace, because this is something where the medical industry, for example, where your accountability actually becomes your credential. So how much the information that a particular AI actually is giving, or the decision that it has made, why these decisions were made, right? So these kind of questions are actually very important to be answered. So obviously there's a regulating body where they come ahead and they do give you certain clearances. There are certain regulations which you need to follow. So in aerospace there are 2 regulations. One is FAA. So obviously we'll have to go through this. We have to get all the certifications, even the software if I need to release, and it has to be with respect to the cybersecurity aspects, I need to follow that regulations what they have set. And similarly DOD, which is Department of Defense, so I need to take my case through them and get it authorized, and then only I can release that particular AI.
We have one question from LinkedIn. This Angelo also was asking, what machine learning models are being used is what he's asking.
Machine learning models in aerospace, it's a very vast industry. So obviously, as I mentioned, what is the situation, what is the scenario? So based on that is what the ML is built. And whatever the situation ML is built, you still actually will come to the next step of analysis where you're asking the AI to go ahead and decide to make certain decisions, right? So why these decisions were made was something which is very logical question. Like if at all you're working with a stakeholder. And irrespective of what ML is like, it makes a decision, but it is not very clear. And there is error thrown up. I don't know where to go and search for. I don't know how to debug that error and how these errors actually came into existence. I don't know. Similarly, if at all I have an XAI, so I have to go a step back and say that, okay, I'm going to be using this concept. XAI is just a concept. So I'm going to use this concept. So when I'm using this concept, I have certain checklist saying that, okay, I need my 4 preliminary pillars to be answered. As I mentioned, those 4 concepts become part of my XI, where I say that, okay, it has to be having certain white box. It cannot be on the giving me some kind of error where it's a black box for me. So it becomes more of an authenticated information, more transparent, and then I go ahead and execute my ML codes. Hope this answered.
Yeah, got that. We have another question. It says, it's asking, what are the main benefits of incorporating XAI in terms of, safety and efficiency of air travel? Is basically, I think, it's what getting at.
Yeah. So efficiency actually is something the information that comes from your operational data, right? So the operational data has to be at all the time your real data, where this information actually is flowing down from the proper authenticated source. So now when I have certain information coming in and I want to improve the efficiency. So I cannot just go ahead and bring in some algorithm saying that, okay, I think the efficiency of this product was this, and I'm going to bring in certain algorithms and I'm going to give 2 times more efficiency. So that is not possible. How am I going to prove that? So that is what XAI comes back into picture, saying that, okay, now you give an explanation saying that how is your logic working? How are you proving that this is something is giving you 2 times more efficiency in your model or in your component? So that explanation brings into more stakeholder questioning. So I'm going to involve my stakeholders. I'm going to involve more of my user to be part of the whole journey, saying that, okay, see, Mr. X, this is where the model is working. And probably today I'm at 0.5 efficiency. And your expectation is like 2 times more, 2x, right? And it may work, it may not work, but this is an iterative process. And I'm going to be involving this particular stakeholder all through the journey. And that is where the XI, when you're modeling, it keeps asking you, what does your stakeholder say? Why is he not agreeing to what you're mentioning? Yes or no? So there is a certain checklist where it has to pass through that. Without the stakeholders sign off, I'll not be able to go ahead and model my ML. So XAI brings that mandate culture as part of the whole execution of the task.
Oh, got that. Yeah, that was very well explained. Yeah, and they're asking one more question, how does this XAI contribute to passenger confidence and trust in AI technologies, generally in the aviation business?
Right. For example, if I've been asked to share my passport details, will I share? No, right? Because that's such a confidential information, right? So, but today, when you're going ahead and trying to get in your smart check-in, for example, in India already we have DigiYatra and we have other web check-ins and all that. You trust, right? You trust the airliner saying that, okay, I'm giving my personal contact number and it is used for only for that particular for that particular reason, for that particular activity that has to be completed. So when I'm giving that information, so obviously that means there is a trust built in. Similarly, when a passenger being asked to share certain information sitting in the flight to fill in his immigration check. Today we go back and we are in a transit and we're at the port and we stand in the big queue because there is an immigration check and an immigration officer actually has so many questions. So I'm trying to build that trust with the passenger, saying that, see, these are the benefits. This is what I'm trying to build a model for benefit of a traveler. And I'm asking you these questions. So I did actually conduct a survey on this because this is such a confidential information. And I asked a couple of them, are you ready to share your passport details, your the country that you're traveling, because I need this information for the immigration checks, and how does it benefit the further generations to come. So few answers were like yes, because I have faced a lot of challenges, at the port, at the transit port, and I'm ready to give certain, may not be authenticated information at part of this time, but when I've been asked, I'm ready to share this because it's going to be coming out actually as a benefit for the next set of passengers who will be traveling, or it may be a benefit for me as well. Similarly, the baggage that you're carrying to the airport should be having an RFID tag, where we are recommending saying that you have to give your phone number so that you can track real time. You can see your baggages at the conveyor belt. So when the benefits are well explained, so the confidence and the trust is automatically built. So it's a two-way kind of an engagement, right? So XAI, obviously, that today we are talking about explainable AI in such a depth. I would also want to watch for that, where your information that as a customer or as a passenger is given, it is kept confidential. It is not misused. This is one of the advantage of using XAI.
I got that. Sandhya, we'll take the last one here, okay? It's one of the participants is asking, how does XAI help pilots in the aviation personnel, right? To understand complex AI-driven decisions in real time, okay? I can give you an example of what actually this question is pointing to. Remember the Dreamliners, the first, which got grounded all over the world when the Boeing Dreamliners came in, where the inputs of the pilots was being translated into something else, as whether the functions of the of the plane. So the people did not understand what happened, and it led to a few crashes. And then the next thing, we grounded everything to get to the bottom of actually what has been happening, and how do pilots, in today's world, try to understand these, complex, these decisions which is made at the avionics level. I think he's asking this question.
Yeah. So to give you a quick, response to that, see, certain informations, what happens in the cockpit is confidential, right? And certain operations or the decisions that the pilot actually is taking is highly confidential. And until unless the pilot doesn't want to share, right, to their authorities or to their stakeholders, we common people like us cannot access that information. But said and done, when we are talking about the XAI coming into picture, the pilots actually have something called as connected app today, right? And where they can actually monitor, they can actually get the fingertip information at their fingertip, saying that how each of the ground step before they took off, what all activities were performed, and how confident they are to take up to take off, and what kind of support they would need. And there is a constant communication that is happening from the cockpit to the ground staff. And in between, it is up to the pilots to throw that information also to the passengers, saying that, yes, you're all safe, nothing is wrong. But the other way, he's communicating, saying that there is some technical error and technical glitch happening. But is it something that, when pilot is trying to make us mentally prepared, or he doesn't want us to be prepared, there are certain scenarios how the pilots are trained. Now, when it comes to certain information that has to be kept confidential, it is within the cockpit. That does not mean that the operational information cannot be shared. For example, Lufthansa came up saying that they put certain penalty on the pilot, saying that they were expected to come out with a fuel efficient, to save certain fuel, to make it more efficient with respect to the fuels that are using, and certain SOPs were actually given to them to follow. But pilots could not take the decision because safety was a major concern, right? And they cannot go ahead and share this information publicly, because we are in that, supporting Lufthansa on services and things like that. Certain informations are given as a case study. So this information which pilots are using obviously cannot be shared. It is highly confidential until unless only the stakeholders need it. I hope I made that clear.
Yeah. Actually, the last point you just made, where the control towers, like we had an incident like that which happened just this week with Vistara Airlines, where they aborted the takeoff when they saw something coming through from the control tower miscommunication. Anyway, thank you so much. Right now, I think we are run out of time. It's been a very interactive session, and thank you for taking your time out. I know you've been, you have a very busy schedule. We really appreciate you taking your time out for us and, helping us out in, and trying to make sure that, the next generation of, the people who are actually the workforce, get to hear the use cases from your side, and then hopefully take up, machine learning and artificial intelligence as the career. Yeah. Thank you so much again. Thank you everyone for joining in, and thank you, Sandhya.
Thank you. Thanks, Ram.
Have a nice day.
Thank you.
Bye-bye, everybody.
Bye.